Objective, standard deviation. Definition number 1. Deviation, the amount a single measurement differs from a fixed value such as the mean. So we have a dot plot and we have the values 1, 2, 4, 8, and 10. If you add these together and then divide by 5, because there are 5 data values, we get a mean of 5. So I've denoted the mean using X bar. And sometimes you will see X bar or mu, which is a Greek letter. So what does this mean? Well, we have 4, which is one value or 1 unit left of 5. So the deviation from 4 from the mean, or the deviation of 4 from the mean, is -1 because it's one value to the left, 1 unit to the left. 2 is 3 units left of 5, our mean. 1 is 4 units left of 5. 8 is 3 units to the right of 5, so +3. And 10 is 5 units to the right of 5. So if we take all of these deviations and we add them together, they're going to give us 0 because that is our mean. Now this doesn't really tell us anything. We can just see which values or how much each value is away from the mean. There are 2 ways to find or calculate deviation. Definition number 2, mean absolute value, mean absolute deviation, we abbreviate MAD, is the average absolute value of the deviation from the mean. And definition number 3, standard deviation, we can abbreviate SD, the square root of the sum of the squared deviations from the mean. So I'm going to show you how to calculate both of these, and you've probably seen mean absolute deviation before. So mean absolute deviation, MAD, using the deviations from the previous slide, and those were -4, -3, -1, 3, and 5. So the first step, find the absolute value of each distance or deviation, because the deviations are the distances that each data value is away from the mean. So take the absolute value of each of these data points and we're going to find the average. So -4, the absolute value is +4, -3, 3, -1, 1, 3 is 3, and the absolute value of 5 is 5. Remember, absolute value has to be positive. It's the distance the number is away from 0 on the number line. Step number 2, find the average of the absolute value of the deviation. So again, we're finding the average, which means we're going to take these absolute values and add them together and then divide by 5, because there are 5 values, 1, 2, 3, 4, 5. So add these together, you get 16, and 16 divided by 5 comes out to be 3.2. So the mean absolute deviation is 3.2 units above or below the mean. So we're talking, here's the mean, and most of our data on average is going to fall between -3.2 units away and +3.2 units away. This would be one standard deviation, either below or above. Standard deviation, SD, using deviations from the first slide. So again, we're using these same values. First step, square each deviation. So -4 squared. You have to have parentheses here if you're typing these in your calculator. Otherwise, you're going to get the wrong answers. So -4 squared means -4 times -4. And a negative times a negative is a positive. So positive is 16. -3 squared is +9. -1 squared is +1. 3 squared is 9. 5 squared is 25. Now, just as we did before when we were calculating the mean absolute deviation, we're going to find the average. So add these together and then divide by the number of values. There are, again, 5 values, so we're dividing by 5. Add them together, you get 60. 60 divided by 5 is 12. Now we have one more step here. Because we squared everything, we need to undo what we squared. So undoing something squared is taking the square root. So we're going to take the square root of 12, and you can do this on your calculator. You get about 3.46, so we're going to round and say 3.5. So the standard deviation is 3.5 units above or below the mean. So the mean is 5. Most of our data is going to be within 1 standard deviation above or below the mean, and you can see this on the number line. Now, standard deviation, the formula. So there's a formula to do that last process, and I wanted to introduce the process before I showed you the formula because this looks pretty overwhelming. Now, this symbol right here is what we use to denote standard deviation. It's called sigma. This is a lowercase sigma, and this is standard deviation of the population. We have the square root. This is a capital sigma. It's a Greek letter. This one's uppercase, and it means summation or sum, the total. The total of this quantity. Well, X means an individual value, so just a data point. On our number line, we had 1, 2, 4, 8, and 10 as our data points. So those would be our X values. Mu, or X bar, sometimes you'll see X bar, tells us what the mean is, the population mean or the sample mean. Those we subtract and then we square them. So this is the difference that our value is away from the mean, and then we square those values divided by the total number of values. So N is the number of data points in our sample. In our case, we had 5. Vic number 1, when finding standard deviation using the formula, remember to use the order of operations. So in the order of operations, we would do what's inside parentheses, so we subtract. So we found out how far our data was away from the mean. Then we're going to square them, so we squared each of those values. Then we'll do the summation, so add them all together and divide by the number of values. And then finally, we'll take the square root, so that would give us our answer. A large standard deviation, Vic number 2, a large standard deviation indicates a large range in data values. The data is more spread out. So if you have a larger standard deviation, the data is more spread out. If you have a smaller standard deviation, the data is pretty close to the mean. All right, now an example using the standard deviation formula. So the best form is to put it into a chart. So we have X, these are our data values, and these could be in a list, 12.6, 5.1, 11.2, 17.9, and 18.2. Our mean, so mu, or sometimes you'll see, again, X bar. Okay. Now, to find the mean, you take your data values, you add them together, and you divide by the number of data values. So there are 5 values here. Add these together, divide by 5, and you get 15. 75 divided by 5 is 15. Now, N is the total number of values, 5. That's why we divided by 5 here. So I've broken this down into a smaller process. We're going to say our data value, 12.6, minus the mean. So 12.6 minus 15 gives me negative 2.4. 15.1 minus 15 is 0.1. 11.2 minus 15 is negative 3.8. 17.9 minus 15 is 2.9. And 18.2 minus 15 is 3.2. So I'm just subtracting. Now I'm going to take the values in this column and I'm going to square them. So these were my deviations from the mean, and I'm going to square those deviations. So if you do negative 2.4 in your calculator with parentheses around it and you square it, you get 5.76. 0.1 squared is 0.01. Negative 3.8 squared is 14.44. 2.9 squared, we can do that, and we get 8.41. And 3.2 squared is 10.24. Now we've squared all of our values. We're going to find the sum of all these squared values, and we're going to divide by n. So add these all together. 5.76 plus 0.01 plus 14.44 plus 8.41 plus 10.24, and you should get 38.86. And we're going to divide by n. Now remember, n is equal to 5, so we actually have 38.86 divided by 5, which comes out to be 7.772. And I'm going to keep all of these decimals until the very end. I don't want to round until I absolutely have to. Now, standard deviation. This is the formula for standard deviation. The sum of the quantity x minus mu squared divided by n. So we found this inside value to be 7.772. So I'm going to now take the square root. Our very last step will be to take the square root. And you want to use the whole value. So at the very end, you can round 2.7787, so I'm going to say 2.79 would be my standard deviation.